Let's take a look at some of the problems that we're going to complete for the area and distance problems section. The first problem here says, use the given definition with right endpoints to find an expression for the area under the graph of f as a limit. Do not evaluate the limit. So let's start by taking a look at that definition. The definition says that the area A of the region S that lies under the graph of the continuous function f is the limit of the sum of the areas of approximating rectangles. So that is, the area is equal to the limit as n goes to infinity of the right Riemann sum. All right, so let's quickly, before we jump in, just remind ourselves of a few sort of definitions here. Again, if we have an interval from A to B, we are going to subdivide said interval into n equal subintervals. So pay attention to the partition points and how they are labeled. The very left-hand partition point, A, is going to become x sub 0, and then each partition point will be labeled as x1, x2, x3, and so on, until we finally end with the very right-hand partition point, x sub n equal to b. Now, we might be required to provide some values for each one of the partition points, like state exactly what they are. And so we can easily calculate those. First of all, note that delta x, that is the size of each subinterval, is going to be equal to b minus a over n. So that is the total length of the interval divided by the number of subintervals. So you can see that as we move from a to x sub 1, I moved 1 unit of delta x to the right. So x sub 1 becomes a plus delta x. So similarly, the second partition point, x sub 2, is going to become a plus 2 times delta x, and so on, so that we can generically say x sub I is equal to a plus I times delta x. So back to my problem here. The function that I'm given to work with, f of x, is equal to x squared times e to the x, and we're working on the interval from 0 to 5. So the first two things that I would like to determine here is, number one, what is delta x? So for my problem, delta x, remember, this is b minus a over n. This will be 5 minus 0 over n. So we can just simplify this to 5 over n. I'm also going to need to give an expression for x sub I. So remember, we just said that x sub I is a plus I times delta x. So for my problem specifically, this is going to be 0 plus I times 5 over n. So let's just write this as 5i over n. So let's plug in to our formula here. All right, so a is equal to the limit as n goes to infinity of the sum, I going from 1 to n, of, first of all, f of x sub I. And again, let's just quickly get this straight. So f of x sub I is going to be x, but we're going to replace x. That x sub I will be 5i over n, quantity squared, times e raised to the x. So 5i over n. All right, so this is my function. I'm going to put that over here. 5i over n squared times e raised to the 5i over n. And now we need to remember to multiply this by delta x. For my problem, this is 5 over n. All right, so let's take a look at another problem in this section. The next problem says, determine a region whose area is equal to the given limit. Do not evaluate the limit. So again, I would like to just quickly take a look at, again, the same definition that we just saw, that will give us expressions for both delta x as well as x sub I. And then remember specifically that the definition of the integral, so that is the integral from a to b of f of x dx, is equal to the limit as n goes to infinity of the sum, I going from 1 to n, of f of x sub I times delta x. So keeping those in mind, back to my problem, what I would like to do is, I'm going to kind of just write this problem again, and what I would like to do is kind of this like almost direct kind of a comparison here. So if I just rewrite the problem, I'm just going to, instead of 1 over n times I over n to the fourth, I'm just going to kind of switch those two. Remember, multiplication commutes. And then what that allows me to do is to note that if I compare this to the formula, you can see that the I over n to the power 4 corresponds to the function evaluated at x sub I. And then the 1 over n in my problem corresponds to the delta x. So I'm going to start by saying that, all right, we can see that delta x, which we know to be b minus a over n, in this particular problem is going to be equal to 1 over n. So what this tells us is that b minus a is going to be equal to 1. So the difference between the two is 1. So we can see in these answer options that are given, that's true for all 5 of these possible answers. So let's take a look next at the f of x sub I. All right, in this problem, again, we know that f of x sub I, by definition, is a plus I times delta x. All right, so maybe more specifically, we know that delta x is equal to 1 over n. So that's going to be a plus I over n. Now, if you look at the function that is given over here, we have I over n raised to the power 4. So the only thing that the I over n, so this guy right here, probably needs to be a little more. So the only thing that this right here can be equal to possibly, right? So let's say the I over n is equal to the a plus I over n. And whoops, this tells me definitely that a must be equal to 0. So if a is equal to 0, that means b is equal to 1. And the only thing that my function then can possibly be, if everything here on the inside is the I over n is my x, then that means that the, again, f of x sub I, in this case, is the I over n raised to the power 4. This means that f of x is equal to x to the power 4. So the answer that matches, let me see, answer that matches here is going to be this answer right here. All right. Hope these hints were helpful.